Hey guys, you all have your test tomorrow, which is Tuesday. So hopefully you are going through this with me, this video with me today. I've sent you the practice problems, so you guys should be going along with me. Or even better, if you go ahead and try to solve all the problems on your own and then watch this video just to check your answers, that would be even better for you. Make sure you take your test tomorrow. And then all other grades for this semester are due by Wednesday night by midnight. I have to get your grades in and verified Thursday morning, so I can't accept any grades done past Wednesday night at midnight, so make sure you're on top of that. All right, so let's just go through this little study guide. And if you have any questions, make sure you get in touch with me, send me a message, and I can help answer any questions that you have. So let's plug in 6 for x and see which of these equations, or excuse me, inequalities are correct. So if x is 6, we're going to multiply 4 times 6, and we would get 24, and 24 times 1 is 25. So this says that 25 is greater than or equal to 25. Is that true? Is 25 greater than or equal to 25? Yes, it is. It's equal to, so that counts. So if I plugged it into this equation, the numbers are the same, so I would still get 25 on the left side. This one would tell me that 25 is equal to 25. Is that true? No, that is not true. So this is the inequality that makes this value of x correct. And why? Because 25 is not greater than 25, but it is equal to, right? All right, let's look at the second one. Sally bought 5 pairs of pants that were on sale for $66.25. Each pair costs the same. So since we know that she bought 5 pairs and each cost the same, and we know how much she spent in total, then we're going to write in, we're going to use a variable to represent the price of each. So we'll say x is equal to the price of each pair of pants. So we bought 5 of them, or Sally bought 5 of them. 5 times the price of each pair is equal to $66.25. So that's our equation. Remember, equations have equal signs. So if you're supposed to write an equation, make sure you have an equal sign. If you write an expression, expressions do not have equal signs. All right, so now we're going to solve the equation. So this says 5 times x. So the opposite of multiplying by 5, we're going to divide both sides by 5. 5 divided by 5 is 1. So in our calculators, we are going to say, what is 66.25 divided by 5? And we find that the pairs of pants are $13.25 each. That's it. Oh, and prove your answer is correct. Well, then I would just plug our value of x back into the original equation, because I want to do what it asked me to do. So 5 times 13.25, plug that in my calculator, and I got 66.25. So yes, my answer is correct, my solution. In order to vote in Georgia, a person must be at least 18 years old. Write an inequality to show the age of people that are allowed to vote. Graph it and discuss the number line. So if you must be at least 18, can you be 18? Yes. Can you be older than 18? Yes. Can you be younger than 18? No. So X represents the age of people who can vote. That age must be greater than or equal to 18 years old. All right, so if we have our number line, 5, 10, and then 18 be about right there. So are we going to fill in that circle? Yes, we are, because you can be 18, or you can be any number to the right of 18 on a number line. Now, obviously, this goes for eternity, and there's an infinite number of solutions. However, would it make sense that we would say that x can be equal to 200? No, it wouldn't, because people don't live to be 200 years old, right? So even though this is the correct way to graph our inequality, according to this situation, only answers up to what? 105, 107. Not very many people live past 107, right? So anyway, so just think about that when you are graphing inequalities. Even though this is technically correct, it is. But if you had to discuss the number line, you would say, well, only answers up to about 105 would make sense, because people don't live much longer than that, right? And most people don't live to be that old. So look at the next one. Jordan runs 6 miles per hour. Write an equation to represent the scenario. So let's say, so since we have to have an equation, and Jordan runs 6 miles per hour. So here we have two different quantities, right? We have two different things here. We have miles and we have hours. So we can say that the total number of miles equals y, or excuse me, y equals the total number of miles. We could let x represent the total number of hours. So those are our variables. So now we can write an equation. So the number of miles is equal to 6 times the number of hours. Then it asks, what is the dependent and what is independent? So the dependent, so the number of miles we run, or Jordan runs, would have to depend on how many hours he runs, right? So that makes y our dependent variable, and x is independent, because Jordan could run 0 hours, or he could run 1 hour, or 5 hours, or 10 hours. So that's independent. But however many hours he runs, that totally will affect how many miles he runs. So it says, so we've done the first statement. We've written an equation. We have described we picked out the dependent and independent variables. So describe the relationship. So we're going to say the number of miles depends on the number of hours Jordan runs. So that's a good way to describe the relationship, right? And then it wants us to come up with a little t-chart. So if x represents hours and y represents miles, if he runs 0 hours, he would run 0 miles. 1 hour, he would run 6 miles. 2 hours, he would run 12. And 3 hours, 18. So that's a good number of coordinates to put on our t-chart. All right, number 1 on the next section, what makes this equation true? So we're going to plug in each of these values until we find the right answer. So what if x is 4? So 3 times 4. Well, 3 times 4 is 12, and is 12 times, or is it 12 plus 5? 23. Nope, it isn't. That's 17. 17 does not equal 23. All right, what if we use 5 for x? So 5 plus 3 times 5 equals 23. 5 plus 15. Does 5 plus 15 equal 23? Nope, that would be 20. 20 does not equal 23. All right, let's try 6. So if x is 6. Well, 3 times 6 is 18. And is 5 plus 18 23? Yes, it is. That is correct. 6 works. Well, of course, 7 is going to be more than 23, right? Because 3 times 7 is 21, and 21 plus 5 is not 23, it's 26. So there we go. So 6 is the only answer that makes that equation true. All right, what about number 2 right here? So we're going to plug in 2 for x. 5. And we're going to plug in 3 for y. And we're going to see if this statement is true. Well, I know that 6.5 doubled is 13. And let's see what 5.25 times 3 is. It's 15.75. So finally, we're going to add 13 plus 15.75 plus 15.25 equals 44. Is 44 greater than or equal to 45? No, it is not. 44 is not greater than or even equal to 45. So we just plugged in those variables, those numbers for each of those variables. Number 3, Shane had $50. He bought X number of candy bars for $2.50 each. Write an expression to show how much money he has left. All right, so an expression does not have an equal sign. So let's see, Shane started out with $50, right? And if you spend money, are you adding to how much you have, or are you taking away from how much you have? Well, he spent, so we're going to subtract. We don't know how many candy bars he bought, but they were $2.50 each. So we're going to say 2.5 times X. And that shows how much money he has left. Or we could have said, all right, we're going to spend $2.50 times the number of candy bars, but he had $50. So either of those is correct, and they are equivalent. They're exactly the same. So make sure if it's asked for an expression, no equal sign. That's a big, big hint. All right, number 4, we want to solve for X. So that means we're going to cancel out whatever's on the side with X. Well, on the side with X, I see plus 8. So what's the opposite of plus 8? Subtract 8. So we're subtracting 8 from both sides. So 17 minus 8 is 9. And then we can double check our answer by plugging in 9 for X. 9 plus 8. And 9 plus 8 does in fact equal 17. So we know that answer is correct. Number 5, Rick, Mark, and Kevin worked a total of 18 hours at the golf course. Mark worked 6 hours, Rick worked 5. How many hours did Kevin work? Write an equation and solve it. So there's our equation. Equations have equal signs. Well, my goodness, my pen stopped writing. Why did that happen? Ah! It's acting like it's gonna draw. Come on. Oh, it started working again. Huh. All right, so sorry about that. So 6 hours for Mark, 5 hours for Rick. How about Kevin? I don't know. We don't know yet, do we? And they all together worked 18 hours. So K represents the number of hours that Kevin worked. So we're going to add our like terms. So 6 plus 5, we can add those. So we get 11. And now to solve for K, we get rid of this positive 11. The only way to get 11 gone is to subtract 11. We do everything twice. Bring down our K is equal to 11 minus 18 minus 11 is 7. So Kevin worked 7 hours. That's it. All right, number 6, 3 times x is 21. So the opposite of multiplying by 3, we're going to divide both sides of the equal sign by 3. 3 divided by 3 is 1, and 1 times x is x. And 21 divided by 3 is 7. And then we could plug that in. Does 3 times 7 equal 21? Yes, yes, it does. All right, number 7. One way to get rid of times a fraction is we're going to multiply by the reciprocal. So the reciprocal, if you flip a fraction, right? You flip it. So if I flipped 1/4, I get 4. So I'm going to multiply both sides by 4, or 4 over 1. 4 over 1 is equal to 4. These cancel. So I bring down my x is equal to 7 times 4 over 1, or 7 times 4 is 28. So then I could double check that. Is 1/4 of 28 7? If I multiply straight across, I get 28/4, and 28 divided by 4 is 7. So that is true. My answer is correct. Number 8, the least x can be is 15. Write an inequality to show this. So the least x can be is 15. So can x be 14? No. Can x be 15? Yep. Can x be bigger than 15? Yes. So x can be greater than or equal to 15. It cannot be less than 14. Or excuse me, it can't be less than 15. So on our number line, 14, 15, 16, we would circle 15 and fill it in because it has an or equal to sign. And then our arrow, if this were an arrow, it would definitely be pointing to the right. That arrow and that inequality sign look the same if your variable comes first. Number 9, Jeff needs at least $76. So let's say you go to the mall and you said, Mom, I need at least $20. Does that mean you could take $20? Yep. Does that mean you want $15? No. Does it mean that really you want more than $20? Yes. So at least 76 means $76 or more. X, you want X to be $76 or more. However, he already has $52, right? You can't ignore that. He already has $52. So let's see how much more Jeff needs. So 6 minus 2 is 4, 7 minus 5 is 20. That means that Jeff needs $24 or more, right? All right, so if I got more than $24, would that be the only answer? Well, it's close, but because of that sign, the word at least means I can take $24 or more. If I take from 0 to $24, that does not give me at least 76. So these two don't make sense, because if Mom only gave me $6 and I had 24, I only have $30, but I need 76. So that means the best answer is this one. So like I said, the top one would give me $76, but that word at least means I want 76 or more. Okay, so the second one is the best answer. All right, number 10, which equation matches this table? All right, so let's plug in these coordinates for X and Y. So Y is equal to 5 plus 8. Is that true? Does 13 equal 5 plus 8? Yes, that one works. However, we definitely want to check more than one coordinate because it might only be true for one of them and not true for any of the other ones. So let's try the second coordinate. So Y is 17. Does 17 equal 7 plus 8? Nope, 7 plus 8 is 15, which means that A cannot be the right answer because it doesn't work for every coordinate. All right, let's look at letter B. Does B work for every coordinate? Well, let's see. Let's say we pick the first one again. Well, if Y is 13 and X is 5, is 13 equal to 5 plus 10? Nope, that doesn't work either, right? All right, let's look at letter C. Let's say let's say I just picked the bottom one. All right, so if Y is 29 and X is 13, well, 2 times 13 is 26. Is 26 plus 3, 29? Oh, that one works. It works for the last one. Let's pick another one. Let's say we pick this one just to make sure. Well, if Y is 21 and X is 9, 2 times 9 is 18. Is 18 plus 3, 21? It is. So that one's right too. So you want to check no less than 2, right? And if I checked the rest of them, I would see that the answer was right for all of them. So C is the equation that matches the whole table. Can't just match part of it, it has to match all of it. All right, and finally, number 11, write an equation that shows the relationship between X and Y. All right, so let's just write down some of these coordinates. So remember, your X is your horizontal axis and your Y is your vertical, and it's even labeled here, Y and X. All right, so let's find whole numbers. So for example, when X is 10, Y is 1. All right, what about X is 20? Y is 2. X is 30 right here. Y is 3. So how do we get Y? Y is equal to, what do I do with X? It's actually going to be 1/10. Because if X is 10, 10 times 1/10 is 1. If X is 20, if it's 20, I get 20 over 10, and 20 divided by 10 is 2. If X is 3, or excuse me, X is 30, let's say Y is equal to 1/10 times 30 over 1, and 30 tenths is 3. So I didn't mean for that one to be a fraction, but it actually turned out to be a fraction. So you just want to make sure, you want to think, okay, what do I do to this first number X to get Y every single time? Well, the only way to multiply and get a smaller number, smaller answer, I have to multiply by a number less than 1, right? All right. But on your test, when you have a problem like that, it won't be a fraction, just so you know, it'll be a whole number. All right, you guys, I hope that helped you. So don't forget, your test is Tuesday. You have to take it on Tuesday, and all of your other work is due by Wednesday. If I don't talk to you guys this week, I hope you all have a wonderful Merry Christmas and a great New Year, and I will see you next year. See ya.